All right, so for this first one, right, what we want to do is, we can write it out. We can always choose to write it out. Ideally, you can also kind of write it out in your head, right? But what you want to picture is that this is this, right? X to the fourth is this, and then it's all of that 3 times. So how many x's is that going to be? Well, you could count, right? But you can also see like, oh, it's 4 x's 3 times. Well, that's going to be 4 times 3. That's going to be 12 x's. Okay, whereas this one, right, this is not, we're not going to end up multiplying, right? Here we did 4 times 3, but here this is n times n times n times, right? What is this? This is 7 more n's. Well, how many n's are being multiplied now? Well, there's a total of 10, right? There's 3 here and 7 more here, so we end up adding. Okay, now, again, you're always welcome to write it out. You can also, just get better at picturing this stuff in your head. A negative exponent means that this is just unhappy where it is on the fraction. Remember, there's an invisible fraction here, and this a to the negative third is not happy on the top of the fraction. It's going to be very happy and positive down on the bottom of the fraction. There's nothing on the top of this fraction, so we just leave a placeholder of 1. So that answer looks like this. Okay. Here's a little bit of a longer question. I observe that I'm going to be taking this fraction and taking it to the third power, but what I want to do is inside check first. Is there anything I can simplify? And in this case, there is. And the reason I can simplify things is because I notice that there's some negative exponents in here. So we can fix that before we do any other simplifying. So let's check the numbers. 2 over 5, that's not a fraction that can be simplified. Let's just bring that over here. This x to the power of 3 is not negative. It's perfectly fine, just right where it is. I'm just going to leave it. Then this y to the negative 2, that's unhappy. This y is unhappy on the top, but it's going to be happy positive 2 on the bottom. And this z unhappy on the bottom, but once I put it on the top, it's going to be positive 4. And now I look, and there's not like x's on the bottom and the top, or there's not like x's here and here. So there's actually nothing else to simplify, so I'm just going to take everything to the third power. Okay, now again, you can write this out. Look, and I'm going to just kind of show you what that would look like, but you can also do it without writing it out. But this is 2 times x to the third times z to the fourth over 5 times y to the second. Now all of that is going to be times this 3 times. And now look, I'm not going to write it out. I'm going to pretend though. I'm going to pretend that this says that all of this is written again here and written again here. So that's 2 times 2 is 4 times 2 is 8. Look, I'm going to make my fraction. This is x times x times x, right? There's 3 x's here, another 3 x's, another 3 x's. So that's 3, 6, 9 x's. Okay, there's 4 z's here, another 4, another 4. So that's 4, 8, 12 z's. And then on the bottom, it's 5 times 5, which is 25, times 5, which is 125. Okay, and then this is y times y times y times y times y times y. That's 2, 4, 6 y's. And this is my answer. Okay, and notice I just drew myself a nice long fraction bar. I can erase off the extra, I suppose. Doesn't really matter. Anything to the 0 power, no matter what it is, whether it's a w, whether it's a 5, whether it's a bazillion, it doesn't matter. This just is equal to 1. Right here, I see that I'm taking something to the second power, but I see, oh, there's some simplifying I can do because I have a negative. That means it's on the wrong side of this fraction. So I'm going to take this, and it's still going to be squared, right? That's just bringing this over. Now notice, look, this part of the fraction is perfectly happy. It's sitting on top of the fraction. It's still going to be sitting on top of the fraction. Okay, this b to the negative 2 is not happy on the top. It's going to be happy down here on the bottom. And now to the power of 2. Look, this time I'm not going to write it out. I'm just going to pretend. So I'm going to pretend I've written out, and it's going to be 7. It's only to the power of 2, so 7 times 7, 49. This is a times a times a times a times another, right, squared, times another a times a times a times a. That's a total of 8 a's, right, 4 and 4. On the bottom I have b times another b times b. That's a total of 4 b's. Right here, this is this. Okay, and notice I'm kind of alternating between writing it out and not writing it out. What I want you to do is eventually be able to just write it out in your head, right? But I don't want you to get away from the idea of writing it out. I don't want you to memorize rules. I want you to just imagine this every time, okay? So let's see what this is. This is 3 times 3. That's 9. This is 3 times 3. That's also 9. And 9 times 9 is 81. I could have also done 3 times 3 is 9, times 3 is 27, times 3 is 81, but okay. This is a total of how many a's being multiplied? There's 4 a's, 8 a's, 12 a's, 16 a's. and then 1, 2, 3, 4 B's. Okay. And in terms of like shortness, right? Like this was 3 to the power of 4. That was 81, right? This was 4 A's 4 times. That's 16 A's. And this is 1 B 4 times. That's 4 B's. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. On the top, 1, 2, 3, 4, 5 on the bottom. Cancel, 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 cancel. And I'm left with 4 N's on the top. Done. Okay. Here I have some simplifying I can do on the inside of this fraction. And what is the simplifying this time? Well, I look at the numbers 3 over 8. That cannot be simplified. I look at the x's. This can be, right? There's 2 x's on the top and there's 7 on the bottom. 2, 3, 4, 5, 6, 7. This cancels, cancels. I'm left with 5 x's on the bottom. And this, for the n's, I have 4 n's on top and 1 n on the bottom. 1 cancels. I'm left with 3 n's on the top. And now, let's go ahead and just take all of this to the power of 2. Again, feel free to write it out. I'm going to do it without writing it out this time. But you could absolutely just, write it out like this. 3 to the power of 2 is 9. This is n times n times n, 2 times. That's going to be 6 total n's. 8 to the power of 2, 8 times 8 is 64. And this is x being multiplied by itself 5 times. So I imagine a list of 5 x's twice. That's going to be a total of 10 x's. Okay. And last one. Here we go. Okay, so this is to me, this is like a great one to just write out. And you can do it all together like this, right? Like, look, that's this part. And then this is this part. So to me, this is a great example of a problem to write out. You could absolutely do it separate. You could kind of, like, I think the way that I would do it if I wasn't going to write it out was kind of do this part of my head and do this part of my head and then combine it. But look, let's just do it this way. What's 4 times 4 is 16 times 4 is 64. Now, for A's, I have 1, 2, 3, 4, 5, 6, 7, 8 A's total. And for the B's, I have 5, 10, 11, 12, 13 B's. Okay, so this is my answer. And again, like the other way I could have done this, right, is I could have kind of done this part of my head and I would have gotten A squared B to the 10th. And then over here, I would have gotten 64 A to the 6th, B to the 3rd, and I would have said, okay, well, I have a 64, and then I have 6 A's and 2 more A's, that's 8 A's, and I have 10 B's and 3 more B's, that's 13 B's, right? So either way is totally fine, but yeah, both work.